Okay, welcome to the video for 3H and 3I. 3H, I can determine if a situation represents a direct or inverse variation, and 3I, I can recognize the graph of a direct and inverse variation. So please pause the video, make sure that you've written down the objectives, and you'll see at the end here on the back, you're going to do a couple problems like that to see if you can meet these objectives. And then, of course, we're going to practice them in class. All right, so what is a direct variation? In a direct variation, as the x gets bigger, so does the y value. So as the x value gets bigger, so does the y value. So what does that equation look like? Well, direct variation equation is y equals k times x. And the constant of variation is the k in this equation. Okay, so where you see the k, that's what we're talking about is the constant. And all that is it's the number that relates the x and the y. And a direct variation occurs when the b, the y-intercept, is 0 or it's just not there. I'll show you an example of that. So let's write a couple of those. It's just a linear equation where the y-intercept is 0 or not there. So if you think about a linear equation, y equals mx plus b, this is the y-intercept. So any equation that's not there, so for instance, y equals 2x or y equals 1/2 x or anything like that, is a direct variation equation. The constant of variation, so the k, is the same as the slope. So you see here the k is right there. In our form for slope-intercept, we write m. And I think what's confusing about this is that it's so simple it's confusing, but it's just the same thing. The m and the k are the same thing. So let's just write m equals k or k equals m, either way. All right, so let's take a look at an example here. Okay, so solve for y. Which of the following is a direct variation? If it is, find the constant of variation. So we're going to solve for y, so we're not going to change, we're not going to actually find out what y is as far as a value or a number. We're just going to change this equation so the y is by itself. So minus 5x from both sides. And I'm left with 8y equals, and when I combine these, it's just going to be negative 5x. Then to get the 8 to the other side, I'm going to divide by 8. So I end up with y equals negative 5 over 8x. So let's go back and answer the question. Which of the following is a direct variation? Well, this one is, so we'll just write direct variation. And then it also wants to know, if it is, what's the constant? So the constant is just right here. It's just the slope, it's just the number in front of the x, it's the number that relates the x and the y. So the k in this case is negative 5/8. Okay, so we're going to do the same thing to this one and determine if it's a direct variation. So I'm going to start by getting the x term to the other side, so minus 3x, minus 3x. These cancel out, and I'm left with negative 4y equals, and keep in mind I can't combine these, so I'm just going to leave it as negative 3x plus 16. Lastly, I need to divide by 4. I didn't leave a whole lot of room here, so I'm just going to work horizontally. So y equals negative 3x plus 16. Divide the whole thing by a negative 4. I'm going to simplify this. A negative divided by a negative is a positive. So I just have 3 over 4x. And then a positive divided by a negative is a negative. And 16 divided by 4 is 4. All right, so is this a direct variation? No, it's not, because we have a b. So no, it is not. Or not a direct variation. Since it's not a direct variation, even though we have a slope here, we're not going to consider it the constant of variation because we do not have a direct variation. And the reason we don't, just to restate it, is because there is a y-intercept here. All right, so let's take a look at this example down here of a real-world direct variation. And keep in mind, as the x gets bigger, so does the y. So a gas station will charge you $2 for every gallon of gas. Create a table, graph, and equation for this situation. So in my table here, I have an x and I have a y. So for 1 gallon of gas, my total cost of gas is going to be $2. If I get 2 gallons of gas, my total cost of gas is going to be $4. And it keeps going up. So as my x goes up, my y goes up. So I go 2, 4, 6. This is going to be 8. And this is going to be 10. So what is this going to look like? And keep in mind, this is what form we want it in. Okay, and we always want our x and our y in the equation, so we need to figure out what the k is. How do I get from one to the other? Well, I have to take the x, so I'm taking the x's, and I'm multiplying by 2. So my equation is y equals 2x. All right, now we'll go ahead and graph it, and you'll notice that there aren't any numbers on here, and you always need to make sure you have numbers on your graph and put numbers that'll fit the information that you have. And I'm going to go up. If I go 1, 2, 3, 4, 5, 6, 7, 8, I'm not really going to get to the end. That's okay. I could also go by 2s, but either way, I'll just go 1, 2, 3, 4, 5, 6, 7, 8. We are going to see enough of the information to kind of see what the graph looks like. Okay, so at 0, if you bought 0 gallons of gas, how much would it cost you? Well, it cost you 0. Okay, so going back to there's no b, there's no intercept, that's because the intercept is 0. So we're starting right there. So 1, 2 would be right there. 2, 4. 3, 6. 4, 8. And we're not going to see our 5 of our 6, and we didn't do 6. Okay, so now you see what the graph looks like of a direct variation, but it's just a straight line. It's just a linear graph starting at 0. So just draw on a line and connect your points. On to the next side, we're now talking about an inverse variation. In an inverse variation, oops, I put that in the wrong spot. As the x gets bigger, the y gets smaller. So let's see what that equation looks like. So if I have y equals, as the x gets bigger, the y is going to get smaller. So I'm going to take my constant and divide it by x. And let me show you how that's going to work. So for instance, let's say our constant's always going to stay the same, right? So our constant of variation is k, and constant always stays the same. So let's say our constant is 100. So I'm going to create the equation where our constant is 100. And now I'm going to plug in some x's, and I'm going to make them get bigger as I go down the line. Okay, so just write in that the x's are getting bigger, and let's see what happens to the y's. So I'm going to start off with 100, and I'll start with a small x of 2, and then I'm going to try 100, and I want my x to get bigger, so now I'm going to try 10, and then 100, and 50. So you can see how my x's are getting bigger as we go down the line. Okay, so what happens to the y's then? So as my x gets bigger, well, now I have 100 divided by 2 equals 50. I have 100 divided by 10 equals 10. And I have 100 divided by 50 equals 2. So you're seeing that as these go down the line, they're getting smaller. Another thing to know about the constant of variation is if I were to take this equation and solve for k, so just rearrange the equation, so get the x to the other side, I would multiply both sides by x. So I take y equals k over x, and I multiply both sides by x. They cancel out over here, and I'm left with x times y equals Okay, so the x and y are always going to multiply to the constant of variation. Okay, so make sure you've written everything down and then follow me down here to try this problem. And I'm going to start with the table here, but we need to travel, or you need to travel, a trip that's 480 miles. You're trying to determine the speed you should travel based on the amount of time you want to drive. So you're going someplace and you're going to have to travel 480 miles. So no matter what, we're going 480 miles. So I'm just going to fill in this whole table here with 480 because we want the distance traveled to stay the same. Okay, so this is our constant. Okay, here are x and y. So what can we multiply by 1? Remember that our constant is the x and the y multiplied together. So what can we multiply by 1 to get 480? We can multiply 480 by 1. Or you could also think of it back up here, how I took the constant and divided it by the x. So 480 divided by 1 does equal 480. Okay, on this one, 480 divided by 2 equals 240. And just to double check that, if I go 2 times 240, it does equal 480. So what we're talking about is miles per hour here. Okay, so 200, if I had to drive, if I only was going to drive for 2 hours, I'd be going 240 miles per hour, which is really fast, right? If I was going 1 hour, if I only want to travel for 1 hour, I'd have to be driving 480 miles in that 1 hour. So what if I was driving for 3 hours? It would be 160 miles per hour that I'd have to go. Getting a little bit closer to what a car can actually do, but probably not something I still want to be doing. If I drove for 4 hours, it'd be 120 miles per hour. If I drove for 5 hours, 96 miles per hour. And then if I drove for 6 hours, I'd have to be going 80 miles per hour. And my chart stops here, but we're starting to get closer to something that we could potentially drive, a speed we could potentially drive at. Just to continue this, just to make a point. But now if I went 7 miles per hour, I would be going approximately 69 miles per hour. So this trip, where I have to drive 480 miles, is probably going to take me 7 hours. Okay, so what's this equation going to look like? And remember that our equation, y equals k over x. What is our k? Well, our k is this 480, right? So we're just taking our x and y, and each time would multiply to 480. So our equation for this is y equals 480 over x. Now let's come over here and see what the graph of this equation would look like. So across the bottom, I'm just going to go 1, 2, 3, so up by ones. And then going up here, if I go up by ones, I'll never get to 480. I won't even get close. So let's go up by 50s. So 50, 100. Oops. Okay, so we're not going to get all our information on here, but we'll get a lot of it. All right, so 7 over here is at 69, so I'm going to say it's about right there. 6 is at 80. 5 is at 96. We want to lower this one a little bit. 4, we're now up to 120. 3, and we're just going to keep graphing these points. 2, 240, and 1, 480. So it's going to be someplace up here. So as you can see, as it's coming down, it's not a straight line. It's more of a curved line, and that's what you really want to notice about inverse variation. As it doesn't create a straight line, it's not linear, it's curved. Another thing you're going to notice is it never crosses the x-axis. It keeps getting closer and closer and closer, but it's just slowing down as it gets closer. Okay, so here's our equation, our table, and our graph. We now see what an inverse variation looks like. And I'm flipping over to the front. We see what a direct variation looks like. So there's a couple problems down here at the bottom for you to try. Okay, here are some situations. So the cost of a jug of milk and the amount of jugs you buy. Does it vary inversely or directly? Is this a direct or inverse variation? You have to think about when the x goes up, is the y going up or is the y going down? Okay, that's what you're going to do with these problems here. And then for number 5 and 6, just looking at the picture, can you tell which one is an inverse variation and which one's a direct variation? And we will go over these in class, so just try your best, think about it, and then make sure you write down any questions you still have. Thanks for watching.